Welcome back to the Security Field Day. I'm Suraj, Director of Sales and Solution Engineering at Versa Networks. In this particular session, I'll be introducing you to Versa's advanced cloud security portfolio within the Versa SASE solution. We will discuss how Versa's firewall as a service and the security web gateway functions detect and mitigate today's advanced threats. So users, as we talked about in the ZTNA case, users can come in from anywhere and everywhere. They could be coming in from a branch location or from a remote location. Irrespective of that, one thing that is the same for each or constant is providing the user with advanced security functions so that all of their traffic, whether it is going to a private or public destinations, gets scrubbed. Specifically, if traffic needs to go to the internet, because of all these advanced threats and malwares that are lurking in the field, you need to make sure they get the full protection that they can get, and that is done through our security web gateway function. We provide IP, DNS, URL filtering, antivirus, anti-malware, a complete set of vulnerability scanning using our IPS engine, as well as provide decryption policy to then be able to do deep packet inspection and be able to do that at scale while we are able to decrypt to be able to understand what malicious that particular packet holds within its within the packet. All right. So these are some of the actual capabilities that, in fact, Versa has in our Versa firewall as a service as well as a switch portfolio. Let me actually show that in the actual user screens, gateways that we just accessed to show all the different capabilities. So here you can see under our next-gen firewall, we'll start with the DDoS protection. So under DDoS, you want to be able to, even before you start looking at the packet, you want to make sure you actually do so only for valid packets. And that is where DDoS really helps to make sure you apply the DDoS or security policies only for certain traffic. We are able to provide both aggregate as well as classified DDoS protection for volumetric DDoS attack, basically detection and mitigation. So we are able to suggest the rate at which you want to allow users to come in to any specific gateway or your destination. So at an aggregate level, you'd specify what is the rate at which you want to start alerting the user or the administrator, and the activate rate, which basically says at what rate you start dropping them, and at a certain rate, you just basically stop dropping everything that happens on the system. And because of the SYN cookie that we actually have for TCP specifically, we will still be able to allow good traffic to go through well when the bad traffic or bad actors are continuing to be blocked. And using the classified profile, you'll be able to select the source or destination and the pairs of source and destination combination to specifically say which destination or which source and destination combination is basically used to be able to protect a specific type of application. Your email server is capable of handling a certain number of packets coming in at a rate that could be different from your file servers, which could be acting as an entirely different rate. So you're able to specify at a classified level different profiles or different rate at which the traffic can be handled and above which or that will be completely dropped.
Quick question. I wanted to make sure I understand that properly. That rate limiting you just described, does that happen at the edge, say at your Versa client or the edge device that's deployed within the infrastructure, or is that all within the cloud delivered firewall?
This is the cloud delivered firewall.
Okay, so if, say, one of these denial service attacks was happening from within the walls, that would be filtered in the firewall. There would be no way to limit that at, say, the edge devices. So
let me clarify that. So at the edge device, so anything that you see in our security portfolio, in fact, is available both in our cloud-based instance as well as the edge device. So earlier I thought you were asking about the edge client. So the SASE client does not have capability to detect that, but our edge device, in fact, runs the same operating system that our cloud firewall actually runs. And because of that, both the device at the edge as well as at the network or the cloud is capable of protecting you from DDoS. Yes.
Got it. Thank you.
Yeah. So once you actually identify the traffic that you want to actually look at, you want to make sure if that particular user who originates the traffic is in fact allowed to access it. You do so, of course, by authenticating the user. So if the user is coming in from a secure access client or a SASE client, then during the authentication process, you basically understand the user. But then if the user is coming from a branch location, there are multiple ways that we can actually provide authentication, active or passive, both actually supported today. And you also have a capability to say, for accessing a given specific network or an application, you'll be able to specify what authentication they need to go through. For example, for application X, they need to get authenticated somehow within a local database or a different SAML profile. Application Y could be a different AD that is providing the authentication. So you can actually treat whichever application that they are accessing or a network that they are accessing, and based on which you will be able to provide authentication. And once you authenticate the user, you also want to, if specifically the user, the traffic is encrypted, you want to be able to decrypt it. But you do not want to decrypt everything that goes through the system. Specifically for privacy concerns, if the user is accessing a banking application, you want to be able to restrict the level of decryption so that the privacy concerns are basically alleviated. So we do so by providing a capability to restrict what layer 3, layer 4, or URL-based or user-based match conditions to enforce a no decrypt or decrypt policy using our SSL and TLS decryption proxies.
Sorry, another quick question, kind of backing up to that, the authentication piece here. Sure. You described a lot about the authentication and authorization pieces within. I'm coming back to the client that you just described in the previous section. Is that, I guess you could say, authentication token, is that transparency passed to the rest of the system here so that we're not like re-authenticating? Say if I'm going, I connect using the client, I need to access various applications. Yeah. I'm authorized for application A, but not application B. Is that token passed? So I'm not re-authenticating again.
So great question, in fact. So that's again the beauty of our SASE fabric, right? So if the user is actually authenticated once with our SASE fabric, we actually have what we call our Versa messaging service, which gets notified with that particular user's information, which then gets propagated to all of our other gateways. So as long as the device is interconnected or the SASE, if you're running your operating system at the edge, as well as your SASE fabric, which is basically running all of our SD-WAN devices, you'll be able to make sure anywhere the user is authenticated, that information, if the user is locally authenticated using LDAP, for example, you'll be able to get that authentication information propagated using like a WMA agent, which then updates that information to our Versa messaging service, which then propagates that information to all the other gateways across the world. So you'll then be able to identify the user identity, the user IP address, as well as in certain cases, the security token, which is passed on to the user, which then the user uses during using as a browser-based access, also will be used to identify the user. So all of that mechanism gives you the capability to make sure the user is only authenticated once. Does that answer your question?
Yep, I think that answers my question.
Right, thank you.
So to follow on with that, so you're basically doing a form of SSO.
I'm sorry, what is the question again? Sorry.
You're doing a form of SSO because what you're trying to do is say, I have this token somewhere, stored somewhere. Where is it stored? Is it in the browser cache? Where is it stored that I can get it from multiple applications? That makes it secure.
Let me have our security architect address that. Yeah.
Yeah. So once we authenticate the user, right? So we can actually anchor the user on either the IP address or the browser cookie or both, right? For extra layer protection. So when we authenticate the user, the Versa gateway is actually like authenticating the user and injecting the cookie into the browser, right? And that works only for the web traffic and web applications. And in terms of like non-web applications, we rely on the IP address. And in some cases, we can actually anchor both IP address and cookie based. That's how the Versa will identify the user once the user is coming in. Right?
So I have a question.
Sure.
Why are you anchoring it on the IP? The IP is pretty random. Could change too.
Correct.
It seems kind of odd.
Yeah, so that is...
Why are we not looking at something certificate-based here where the certificate private key is stored in the TPM.
Correct. So that is an authentication method, and there's two parts to it, right? So in terms of authentication, we support all the different authentication modes, right? Whether it be LDAP or certificate or CAC-based, or we also support multi-factor authentication. So now, like once the user has authenticated, we need to remember the user for subsequent sessions, right? We cannot authenticate the user for every single request, or in some cases, we may need to like do step-up authentication. So depending on like the need and the security needs, we can configure the authentication policies to actually authenticate using one or more forms of authentication. And you can then configure the anchoring part where we remember the user based on the IP address or the cookie or both. When coming from an on-prem location, the IP address may be reliable, but when coming from the public internet, the IP address is no longer reliable, right? So there, it's primarily like only browser-based, right? So once we actually have a mechanism where we can like restrict the number of concurrent logins per user. So user can use multiple devices to be logging in to a given gateway. So you can say like the user can log in from at most one device or two devices and so on. And we can also configure the re-authentication interval. So for example, if the user authenticated and they're actually using their cookie for like about 10 minutes, then you want to force re-authentication. So you can do that. So there's like multiple options available in terms of how frequently we need to reinforce the authentication part. But once the user authenticated, then we remember the fact that the user has already logged in, and based on that, we can apply user group policies.
All right, thank you.
Thanks, Lou. So now that the user traffic is identified, the user is identified, and it is decrypted, you want to be able to look into the packet to be able to understand whether you need to allow it or not. And here is where the set of unified threat management type features come in. We'll start with the IP filtering. With IP filtering, you'll be able to provide geo-based or geo-IP-based actions to say, okay, traffic going to or coming in from a certain embargoed set of countries, or based on reputation, which basically is able to get a feed for known threat actors. So for example, people who are known to actually have botnets or serve phishing or be able to proxy to hide the identity of the other user. So all of that, you'll be able to base it on reputation, be able to say what is allowed and what is not. So we also have a whitelist and a blacklist policy to come up with your own set of IP addresses that you want to blacklist, or anytime you actually want to allow something that was blocked by reputation or the geo-based IP address, you can actually do so by a whitelist. So you can actually come up with all these different use cases where user going to a specific destination or the specific type of FQDNs, if it is a corporate or the public addresses, you'll be able to come up with the policy to say what is allowed and what is not allowed for a given set of users. And it could be, like I said, based on the geographic based or the reputation based. So let's see.
Real quick question. I guess the reputation actions, that reputation list, is that something that you develop in-house and have as your own IP, or is that something you pull from partners?
So we have both. So we do have a security team that actually creates or comes up with the list of bad actors. So we do get our security packs from our own security team, which then gets that fed into each of our cloud gateways as well as the on-premise SD-WAN devices. But we also get a third-party feed, which then augments whatever that we actually come up with as well. So we kind of basically, to answer your question, we use both.
Great. So quick follow-on to that, how often is that refreshed? So obviously things change, things are dynamic. How often is that data updated? So, things are added or removed depending on
technically, as soon as our security research team comes up with the newer build, which in some cases it could be as many as 2 or 3 within even a single day. So basically it can be more than one specific day, or usually it is a couple of days we'll be able to get a new build out. And specifically your question is valid because there could be new domains that are added and you do not know the reputation of that new domain or what basically is being served out of that. So specifically for such cases, you want to make sure we have a system to make sure we look for the actual when this domain was born and be able to appropriately allow or disallow such new domains to be accessed by your end user. So all of that capability, in fact, is built into our SASE solution.
Great. Do you have a feedback scenario? So let's say if I'm a customer, I have something that I know is actually valid, something that I operate that got miscategorized for whatever reason, age, et cetera, et cetera, et cetera. Is there an easy way for me to report, say, allow this because I know it's true, obviously with some validation?
So great question. In fact, we provide capability to, in fact, do our own predefined one. So that's what I was talking about. So we have out-of-box protection as well as something that you can customize on your own. So our custom objects, in fact, gives you the capability to actually augment whatever categorization that we did, so that you can make changes that is applicable to your own environment. From a feedback or to update something that could have been potentially miscategorized, we do have a feedback mechanism so that we can actually have an alias to our security team, which can then report it back to our team, which then can identify whether something was miscategorized and then update that in the next security update.
Are there SLAs around that? I mean, I'm asking because I know this is an issue that exists in the industry. So I want to make sure that I can help you help your other customers also if there is something that is miscategorized.
I'll let our security architect answer about the SLA.
Yeah, so we definitely have SLA-driven services. So definitely, as Suraj said, we provide a mechanism where even we can notify the end users that, okay, in case of a miscategorization, we can provide an override. So if they're really sure that they really want to go, we can provide a confirmation page, and they can override. That can be configurable option. When customers report to us that, okay, this site is miscategorized, then we can actually provide, because what happens is there's various different kinds of attack vectors, based on which we are actually providing both metadata and or reputation, right? So we provide those reputation values based on DNS domains, URLs, IP addresses, and files as well. So what we do is, we actually source information from multiple different sources. And part of the problem is in the security space, there could be false positives. And so that's why we actually have detailed profiles where we can actually prune out the false positives as much as possible. But if beyond all those controls, we still get false positives, then we have a support team, ready to answer 24/7 follow the sun model, where we take the request from the customers and be able to turn around and update the actual accuracy and false positives and false negatives. We address them in real time. And in terms of the updates themselves, we actually enable real-time cloud lookups. So when some of these security services leverage our cloud, you get up to the 5-second kind of granularity when we update a certain value. It takes effect immediately in a matter of seconds. However, if those are actually being delivered as part of security updates, depending on the frequency of the updates, it may take several minutes, sometimes hours.
Great, thank you.
So with our IP filtering, so let's actually see some of that in action. So I have here two different clients. One, the Ashburn one, which actually is not protected. You can see the SASE client actually is not connected. So this, you can imagine to be a non-protected user. And this one here is connected through our system, our gateways, and gets the additional protection. So let's see what happens when the user actually goes to a suspicious website. So here you can see that this particular blacklisted IP address in our configuration, this particular user was in fact allowed to access. So whereas here, the protected user, when he goes to the same, let me actually expand this IP blacklisted website. So you can see that it basically responded back with site not reachable. So basically it was because it was silently dropped by our IP filtering policy. And the same thing, if the user in fact is trying to access some embargoed website in North Korea, he is not allowed to do so. Whereas this particular user, he goes to the same website, he'll be able to access it because he doesn't get protection that the other user gets. So as an extension from our IP filtering, the DNS filtering also gets additional protection based on your DNS or domain records or SQDN. So you want to be able to make sure a specific DNS query is able to be authorized or allowed to access based on either the reputation as well as based on a specific query type. So we actually have extensive filtering based on a specific type of request, specific type of query type, and you'll also be able to say what query is allowed and what is not. And you'll also be able to look at the response, and based on the response, come up with the policy to say what is allowed and not. And also we can limit the number of recursive DNS queries so that we'll be able to actually avoid DNS amplification type attacks. So our DNS filtering for that matter actually gives you extensive capability to limit the actual type of queries the user can and cannot do. And because of that, any reputation-based, if the FQDN resolves to something, we actually look up the IP filters to actually see whether the IP address was known to contain anything malicious in the past and appropriately block it. And we also tie that to a URL filtering policy as well that we are going to talk about in a short while. So with the URL filtering, we are able to also say, okay, this particular IP address or DNS FQDN resolved to some URL which was known to be a malicious site or a category that is not allowed. So that tie-up between IP filter and DNS filter and URL filtering is something that we basically provide the complete protection for the end user. And of course, with all the other set of features, we also can override your functions or activities using a blacklist and a whitelist so that you can come up with your own whitelist actions. So here, let me actually show that this particular website, which actually has are known to contain something suspicious, phpjavascriptroom.com, where this particular user was blocked from accessing it, whereas a non-protected user who goes to the same thing will be able to actually access it. So this was a known offender in the past that this user was allowed, but whereas in a protected case, he was not allowed to do so. Let me basically.
Is it possible to return the blocking page to the user that is trying to access the restricted website? Because I see that you have the connection reset on your browser,
correct,
or at least to redirect to the third party or the external.
If it is a HTTP based, of course. So here, for example, let me show you the other activities that we can do, right? If it is a URL filtering based, because it is IP or DNS based, you're actually limiting it even before the browser hits it, or even before you actually look at the actual TCP or HTTP session. So because of that, there is no actual captive portal redirection. But here, though, if it is based on the URL filtering policy, so here I'm accessing a social media network site that this particular user was not allowed to. So here the user is basically given a captive portal page. As well as if we can actually, we can also have an override policy. So here LinkedIn, which is still part of the same captive, the social media sites group of sites, is still allowed because he has he's according to policy, he's allowed to do so. And let me show that actually.
So you are doing the SSL offload here.
Correct, exactly.
Okay.
So here you can see that all the different categories of allow and deny policies were based on the category. And we also support both user-defined or predefined categories. So all the billions of websites that are around the world will be able to categorize them into 83 different categories and then appropriately select one that it comes out to. So if I access ESPN.com, will be a sports website and so on. So based on the user-defined, predefined, or if you come up with your own category, you can actually create your own pattern based on URL patterns or string match conditions, and then say what URL need to be allowed and denied, or be provided with other capabilities such as an ask page or a warning or a justification page. So here, let me quickly show that as well. So a gambling website basically silently dropped. There is no user response because we silently dropped it. Job search website here, monster.com, according to corporate policy is actually disallowed, but the user, if he's belonging to HR business group, can actually allow it, can continue to access it. If it is a jobs sports website, by default, you actually want to not allow it, but then you are wanting the user to say, hey, use it as your own risk. So then he can continue to access it. So all of this actually is based on our URL filtering policy, as well as our application detection function as well. Our application detection function, in fact, can detect around 3,800 plus applications today. So Facebook and YouTube, whatever it is, right? So we'll be able to base it on different type of application detection policies and appropriately allow or deny. So, and because we have the encryption as well allowed, we basically be possible. We should be able to decrypt.
Can I interrupt you for a second here? Sorry, yeah. You're moving through a lot of things very quickly. And I
Sure,
want to
yeah.
try to jump back to get to two questions.
Yeah.
So you showed the justification piece. What sort of validation or clarification is there on the justification? You showed just HR user, right? But I mean, anyone could type in HR user, then would they presumably be allowed through, or how does the justification work?
Today there is basically, it is based on an audit. So the IT administrator, whatever the user entered, it gets into our analytics system or get notified to the appropriate IT administrator based on the event that basically triggered that. So you'll be able to get paged, the administrator can get paged with the justification that was provided. So the user basically continues to access it. But if the user was not supposed to access it, because the administrator got paged, he'll be able to come up with a policy in real time to make sure the appropriate action can be taken for any other such session. So currently it is based on the analytics engine and the real-time page that can happen or notification that can happen to the administrator.
Yeah, so I've got a question about, you showed an example there where you're blocking a job search website, which is interesting. What kind of information do you send back to the end user who's attempting to access something over this network so that I can understand that I've been blocked and why?
So here, the captive portal page basically gives you that information. So here, this information that is provided here, right? So this is customizable. You can come up with your own information. You can actually create your own CSS HTML-based web page that can provide the right information based on a specific categories, based on whatever that he's actually trying to access. That way, let's say he's actually accessing box.com, which is not a sanctioned website, but then you want them to actually access Dropbox, which is actually sanctioned and it's part of your corporate file sharing program. So then you can actually say for Box, you can actually have a customized page which says, hey, Box is not allowed, use Dropbox instead. So whatever message that you want to provide to the user, it can be actually customized.
Yeah, so one of them you mentioned that like on the gambling website, you said that would be silently dropped.
Correct.
So presumably it can be configured to silently drop any website. So if I go to look at the website for information about how to join a union, the company can silently drop that information and I wouldn't have any way of knowing that that was occurring.
That is exactly right. So for specifically a reason, I mean, administrators have specific reasons to do specific actions, right? You can silently drop the connections. That way the user does not even know why they got dropped. And if that is the intention, you could actually do so. If you want to provide a friendly message, you could actually have the captive portal page to say what information that you need to provide to the user. Yes.
Okay, thank you.
Yeah,
yep, and I just want to ask a question since we're right here in the filtering section regarding IP filtering, DNS filtering, and URL filtering. What mechanisms do you have to ingest lists? Let's say I'm a large organization, or I'm a SOC, right? And I'm generating my own lists. I want to store them in a text file so that my tools can grab them from a local repository or something.
Yeah.
Can Versa grab that? Can you ingest that?
So yeah, so we have multiple ways of ingesting logs. So we have Versa's own reputation databases, which can be integrated with customers' own specific feeds, right? So if it's actually kind of like a static list, it can be easily configured through the UI, and at some point, that actually goes beyond the realm of the UI because you're getting large feeds or you're getting feeds too frequently, right? So then at that point, you need to automate the whole process. So what we have is a mechanism where we can have an external component that we provide as part of our solution, which periodically polls a certain website or a certain API server with authentication, downloads the list, and as frequently as every 2 minutes or every hour, whatever that frequency might be, we can actually get the feeds, and then translate into the Versa format and push the files to all the Versa appliances, all the Versa gateways, at scale. And based on that, each of these appliances are now equipped with both Versa reputation databases as well as customers' own third-party feeds. Then we can actually, on a per policy basis, apply only the Versa reputation-based actions or only the customer feed-based actions, or we can combine both, right? So we have a lot of flexibility built into the platform. So we can kind of ingest these feeds in a variety of different formats, so we can actually get IP files, we can get URL files, we can get domain files. We can also get files that are both a combination of IP and port. So all these can be periodically refreshed all at the same time, and then these are actually then mapped into a higher level of abstraction of objects that can be configured in the policy. And we have very flexible policy enforcement options. So we have, in fact, we actually have very tailored predefined actions, as well as the user-defined actions that are customizable. And these actions are actually typed that for an IP level enforcement, there are certain set of actions available. For URL type of actions, these type of actions are available. So the policy can be automatically tuned to depending on whether you're blocking based on URL or the domain or the IP, the corresponding policy enforcement actions will show up, and then you can enforce those actions.
Yeah. Okay. Thank you. Yeah, I was really just thinking about how to ingest, refreshed static data, static lists. I think you answered that. Thank you.
Yeah. Thank you.
Thanks, Ron. So let's try to wrap it up with the last one about actually file filtering and antivirus. We are actually having, we do have file filtering capabilities to actually define what type of file based on a checksum that you want to allow or deny. And it could be based on a list of blacklist or whitelist. So that way you allow certain type of files to be accessed by certain users. It could be based on a protocol as well as a file type that we can actually say what is allowed and what is not. Specifically for blacklist, if you know specific files that you do not want your users to be able to access, for example, you can use it as a data loss or data leak prevention type of an engine to be able to disallow certain users as long as you know the exact checksum of the files that you do not want your users or specific users to access. Here again, based on the file-based action, you can say what type of file is allowed, what direction, and based on that, you'll be allowed or blocked. And based on reputation also, we actually have a feed to understand malicious nature of certain files, for known files at least. We'll be able to get the checksum of that to be validated against our feed and to be able to make sure what is allowed and what is not if it is malicious. And as an extension with our antivirus engine, in fact, we also be able to do so, do a scanning in deep to be able to understand whether the file in fact is malicious, but through our antivirus and anti-malware engine. So we can do so based on specific file type or based on the protocol here, as well as based, and then be able to provide the feedback to the user. And
so, excuse me, do you do, out of all that, I couldn't get it yet, what I was looking for. Do you actually do in-depth analysis of files looking for malware or data loss other things that could be considered for data loss prevention? It sounds like you just did everything based on standard antivirus, which actually doesn't do that. So I have a valid concern here. Could you explain it in more detail what you're actually doing with?
Yeah. So about the data loss, we are going to have the second next thing for using the data loss prevention, which actually is going to have. I'm going to go in deep about what all our feature set we have within our data loss prevention feature set. But then about antivirus, we do have an antivirus that can scan in deep, as well as we actually are going to be announcing something recently or soon. So we'll actually be able to talk about in our private session.
Thank you.
What I wanted to add to what Suraj has already said, so our AV definitely does static analysis. Okay, it's not simply looking at the hashes of the file. So it does do static analysis. Okay, and based on that, it is figuring out whether there is something malicious. The second thing is, which Suraj was alluding to, was advanced threat protection. Using again, what we do is we do basically sandboxing, security based on AI ML, and finally, basically, we also do multi-AV there as well. So those are also mechanisms basically using which we find out if something is indeed malicious. Any question? Does that answer your question? That is this based on a hash, or are we doing analysis, full analysis of the file?
So the last one is about the complete vulnerability scanning engine. So using this, you'll be able to specify what we do have about 30,000 plus signatures based on which we'll be able to detect all the different vulnerabilities on different products across the world. So in terms of, give me 1 second here. Here, you will be able to say based on a specific product, specific operating system, application on application version, we'll be able to actually, we do have coverage all the way from 1999 all the way to 2021. We'll have signature based as well as anomaly based or heuristic based to be able to provide complete visibility into what actually the user is accessing and then appropriately allowing or denying that particular session. We can also provide user-defined action. So you can come up with your own set of signatures that you can then add to our engine, which then can use it to provide additional protection as well. So using this feature to actually classify a certain set of applications that is applicable to your own deployment gives the flexibility so that you can pick and choose. For example, if you have a data center which actually has only Linux-based operating systems involved, then why unnecessarily do a signature match against all the different signatures that we have, right? So we come up with default profiles that let you that you can pick from. So under our vulnerability rules, under predefined vulnerability, we can actually pick from any of the predefined rules to give you the full protection, or you can come up with your own definition of what you want to protect and then come up with or deploy that to a specific location on the on-premises SASE. So quickly wrap it up using from our analytics, the view of it, of all of that we just saw. So you can see that I'm just using the same exact portal for monitoring for the configuration as well as the visibility here. So under threads, for example, we'll be able to see all the URL categories of websites that I accessed, the IP filters that got rejected. So certain IP address that I actually accessed, whatever that was accessed was basically allowed or disallowed. So you can also see was it based on blacklist, based on geolocation rule, and so on. We'll also be able to show all the other details in terms of the file filtering, all the visibility into the different types of files and the actual files that were accessed by the user. And our DNS filtering policy, which also provides what request or response that was allowed or denied when the user accessed certain websites. And then about malware, we'll be able to see, of course, show the antivirus engine that detected certain malware access, as well as our vulnerability set will actually show you all the different signatures that got hit during certain access.
So you demonstrated a lot of features there in a pretty short period of time. Does the user have any sort of wizards or sort of drive-through or other assistance to help you try to generate a comprehensive policy, or do you have to kind of manually jump through things?
Yeah, basically using our we have in our architecture we have three types of user interfaces, right? So the first user interface that we are seeing here is the Versa director, which we call the classic. It's kind of like a Boeing, cockpit, right? So there's a lot of controls, a lot of policies that provides you raw access to all the capabilities of the platform. So on top of that, we have an enterprise friendly UI, right? Where we have more advanced wizards that actually makes the policy definitions and policy management very, very easy. We have another kind of portal, which is the SMB and small business portal, which is even more very simplified, and it makes it even more easy to define policies and security threat profiles. And we also have a mobile application that you can use your iPhone or an iPad to configure all of your secure SD-WAN policies. It's very, very easy to do that. So yes, we do have different kinds of end user experience portals. Depending on which portal you use, you get a different kind of experience.